All right, so let's go ahead and do our 2.6 notes. These are absolute value inequalities. So the first thing that we have here is a little core concept box. And what I want to point out is we have absolute value inequalities, sort of like absolute value equations, where we're going to have to write them twice, just like equations. Now, when we have two absolute values, two inequalities, those are like compound inequalities because there's more than one. So we need to determine if we have and statements or if we have or statements. So look at this first symbol here. That's a less than symbol. And I like to remember this as a less than, as in it sounds like an and. Less than's like an and. So that's an and statement. So we're going to make an and statement out of these. And what we would actually do for this one is you're going to write it how you see it. So that ax plus b is less than c. But we're going to put the same symbol in the front, the less than, but put a negative c. So that's how we're going to solve this and how we're going to write it. This only works if your c's are greater than 0. Not equal to 0, not less than 0, because then we have different things going on. This next one, we have a greater than symbol. So I'm going to write greater, but instead of ER, I'm going to say OR, like greater, like an OR statement. And how we will write those is you write the way you see it without the absolute value symbol. So AX plus B is greater than C, or you do AX plus B. But remember, with a OR statement, you shade a less than and you shade a greater than. So we're going to have to flip this symbol to a less than and then change it to a negative C. So let's go ahead and do some of these examples together now. Example number 1, I'm going to zoom in just to help you see this a little better. So I see a less than symbol, which means we're going to have an and statement. So the first thing you need to figure out or identify is what symbol, what type of compound inequality that we have here. So being an and statement, I'm going to write this how I see it, x plus 7 less than equal to 2. But I'm also going to put the same symbol in front, but with a negative 2. And now I'm going to solve this compound inequality by subtracting 7 from all three sections. So I get negative 9 less than, whoa, something went crazy, less than equal to x, less than equal to negative 5. So that's my solution. And now I just need to graph it. So if I have negative 9, negative 7, negative 5, these are closed circles where we shade between them. Now, example 1b, I see a 0 here. So as soon as you see a 0 or a negative, you need to stop, put on the brakes, and think. Absolute value represents positive numbers. So what positive numbers are less than 0? And that's none of them. So this is a no solution. So whenever you see a negative or a 0, make sure you stop and think what it's asking. Okay, I'm going to skip these on your own and go to example 2a. So now I see a greater than symbol. Greater means greater, or, so we're doing an or statement, so I'm going to write it how I see it, c minus 1 greater than equal to 5, or c minus 1 less than equal to negative 5. Don't forget that we have to flip this symbol and then make it a negative number after it. So we're going to solve these like normal. Add 1 to both sides. So I get c greater than equal to 6. Add 1 to both sides here. I get c less than equal to negative 4. Put the word or between this. There's my solution. Let's go ahead and graph this. I have like negative 4, some number like 0 between, and then 6. These are going to be closed circles shaded to the sides. Part B, whoa, I see a negative. Oh, that means I have to hold on and wait a second. Absolute value represents positive numbers. So in this situation, what positive numbers are greater than a negative 2? So on a number line, what positive numbers are greater than negative 2? It's all of them. Oh, so this is all real numbers. All right, example 2C. First, we need to get our absolute value by itself, just like when we had an absolute value equation. So I'm going to subtract 1 from both sections and get 4 times the absolute value of 2x minus 5 is greater than 20. Divide both sides by 4, get absolute value 2x minus 5 is greater than 5. This is a greater than sign, so which means it's an or statement. So I'm going to write this twice, 2x minus 5 greater than 5, or 2x minus 5 less than negative 5. So I'm going to solve these, so add 5 to both sides. I get 2x is greater than 10. When I divide, I get x is greater than 5. Or when I add 5 to both sides in the next one, I get 2x is less than 0. So when I divide, I get x is less than 0. So I have x greater than 5 or x less than 0. I'm going to do a quick little number line here and graph this. So I have my 0 and I have my 5. These are open circles shaded to the sides. All right, moving on, I'm going to skip these on your own and do this last one here. You're buying a new computer and the table shows the prices of the computers in a store advertisement. You're willing to pay the mean price with an absolute deviation of at most $100. How many computer prices meet your condition? Absolute deviation sort of means like give or take. All right, so I can go $100 over or $100 less. But first I need to find the mean price. So the mean price means we're going to add up all of these numbers over here and divide it by 10 because there's 10 of them. I'm going to cheat here and because I have it written down somewhere else. If I add them all up, you get 6,640. So 6,640 divided by 10 means the mean price is $664. Okay, so absolute deviation. Here's how we're going to set these up. Your absolute, I'm going to abbreviate here, deviation equals the absolute value of x minus the given value. That means what you're looking for is the difference between what you're really getting and what you're looking for. That difference can be the absolute deviation. That's a give or take. But we have to talk about the difference between what you were looking for and what you actually got. So it's subtraction. So we're going to set this up. Our absolute deviation is $100. That means the give or take, $100, is equal to the absolute value of x minus 664. So that's how we normally set this up. But notice you're willing to pay that at most, which means you want to not go over that. So these equal to symbols for us means you want to stay under that or equal to that. You don't want to actually pay more than $100 more than the average price, or you don't want to go less than that. So if you look, if we rewrote this as x minus 664 is less than equal to 100. So that's how we should rewrite it with the absolute value first now. This is an or statement because it's an and statement. It's a less than. It's an and statement because you want to be between the two numbers. So I'm going to rewrite this one more time. Negative 100 less than equal to x minus 664 less than equal to 100. When I add the 664 to all three sections, I'm going to get 564 less than equal to x less than equal to 764, which means you're willing to pay between $564 and $764 for a computer. And the question is actually asking us now, how many of those actually exist? So I'm just going to highlight these. Greater than 564 but less than 764. So I got 1, 2, 3, 4, 5, 6. So your final answer here would be 6 computers.